Day 22. I guess I should figure out these world space strings, which I know I'm gonna need, because that's not gonna cut it. Alright, well, world space strings, or world space glyphs, I guess, are kind of like sprites, but we also don't really want to blow them up. So I guess it's the third thing that we're gonna be drawing, is these world space strings. And well, yeah, I mean, I guess so. So I should probably split this up into multiple files. New file. Call it sprite. And we need another one. Well, the other one's gonna be this one, I suppose, which is gonna be screen. Okay. So that goes in here. Yep. That just, oh my god, I don't care. You know, if it could shut up with the output, that would be just great. Like, that would be so good. Can you mute output? That's sprite. Move it. That's screen. Buffer, yeah. Well, we'll see about the buffer. I want to have multiple buffers. Sampler texture, well, yeah, I mean, we need that in both. Screen, yeah, screen stays. Sprite goes away. Yeah, sprite goes away. Screen stays. Oh wait, that was played, yeah. That was pixel shader for the sprites. Well, I suppose I should just remove this underscore sprite from the PSVS stuff as well. As well as this. As well as this. Right. So what do we actually need? Do we need window dimension? Yes. Atlas dimension? Yes. Camera position? No. Sprite scale multiplier? No. Alright, what's in here? Do we need window? Yeah. Atlas? Yeah. Camera? Yeah. Sprite scale? Yes. So technically it's this. Yeah, I mean, I guess let it keep them separate, whatever. And hopefully all of this, yeah, all of this stays. We know we need all of that. Okay, screen and sprite are split up. Now, the build program needs to change, because it's gonna look for the one file that doesn't exist anymore. We only have 2 entry points. That's this. We have multiple shaders though. Okay, well, if we just assume that oh my god, that every shader has VSPS, which has entry points, which for now that is what's happening. And it's probably not going to change, so let's just assume that that's the case. Well, we know how to read these files, because we're already doing it somewhere. File info. Where am I even constructing the file info? Oh yeah, way up top. Yeah, I mean, this is like super awkward. But I guess it's not that bad. I mean, let's just copy all of that. And this is where the shader stuff is. Alright, shader source. It's gonna change. Alright, so that's not, there we go. Okay, well, yeah, that's fine. Okay. Shader source path. Okay, so we are looking for what? Code, oh my god, code HLSL. Find handle, assert, find handle, do what? This is A, right? Well, okay. Read entire file, shade the source path. I think that's just in find handle. Oh no, that's not find data. We have to paste it or something. Yeah, we do. Okay. Okay, so this is shader source path right here. Okay, so this is actually different. This is find data C file name. So that's the path. Wait, well, we'll see. So that is the path. So we read it in. I mean, I guess I kind of do want the file name. Shader file name. Which is that without the... Okay, just copy it just in case. Infinite memory. Dot start s let. Okay. So there's the file name, there's the path, there's the source, entry points, yep, flags, okay. I mean, the rest of the loop is pretty much the same. We do need to iterate through entry points. Go in here, then let's compile results, then let's compile, then copy the data, there we go, enum add. What are we adding? Yes, we're not adding this. So str enum label label. I guess it's file name without HLSL. %.star_s str slice. Starts 0 and is shader why is it not okay? Shader file name length minus size of dot HLSL. So that many back. Str file name no ext is that. Okay, so then there we go. File name no ext. And I guess underscore entry point. Let entry point. Something like that. Enum label. There we go. I do need to open up generated.c. And of course I need to open up ROR clone there and then find generated.c and press F12 on it. Okay, now it works. Yeah, alright, let's see. There we go. So we got a bunch of errors there. Okay, well, interesting. Sprit and scree. So I've got what? Shader, oh my god. File name no ext, length 5, 1, 2, 3, 4, 5, 6. Shader file name. Length 11. Well, it's 6 plus 5, 11. So minus. Oh wait, there is an null terminator in there, that's right. Yeah, I guess I should just switch these around. Oops. Shader sprite vs and shader screen. That compiles and runs. Yeah, okay, now we have them in multiple files. I guess I should commit that. Yeah, this is fine. Changed a little bit. Okay, so we have less data apparently now. Somehow. Actually, we have two different. How is it working? We have two different. It's not saying anything's wrong. Even though we have two different buffers, I guess they both start with the same thing. So you can like set the constant buffer to something that's greater than As long as it starts with the same thing, it's okay or something? I don't know. It's weird. No errors. Well, if there are no errors, that means that it's perfectly acceptable use of the API. That's deleted, those are new files, yeah. Split shaders into multiple files. Okay. Well, the whole point of this was to actually create a new file called world glyphs or something, like world glyphs, world glyph, HLSL, world glyph. Yeah, it works. I mean, why not? Why not? Okay, screen. Yeah, there. Well, I mean, sure. Let's use this as a starting point. So we have world glyphs. Sampler textures. I'm just gonna do the same texture. Input. Top left. Dim. Dim. They're glyphs, right? So, I mean, maybe. Atlas color. I mean, this seems correct. Yeah, this is what we want. That's what we want. Window dimension, Atlas dimension. Yeah. Okay, well, we're not gonna be doing... Well, are we? I mean, we do need to figure out position and clip space there, so... Which does... Yeah, we still have to do this. Compared to... Okay, so what's the actual difference? Oh, wait, hold on. The vertex shader is actually more similar to the sprites. It's more like this. Index, top left. We don't need to mirror anything. And we don't really have an offset. Yeah, and the dimensions essentially match the dimensions in the... Yeah. It's the pixel shader that's... So we don't need this multiplier. Do we? Do we? Are we gonna be increasing the size of text relative to the size of sprites? Or is it just gonna be the same? I mean, you would kind of expect it to be approximately the same as the size of the sprite. So, maybe. Except that you wouldn't scale it up or down nearly as much. Because then it would just be gigantic. But then again, if you have text, then scaling it up and down, well, I mean, it's numbers, right? It's specifically numbers. And we might even have special numbers for these sprite lists. But then if we have special numbers, specifically to draw as sprites, and we want those to scale up and down, perhaps perhaps they should be outside of the font. And they should just go through the same path as sprites go through. And then we can scale them up and down the same way we're scaling up and down the actual sprites. Never mind, then just the world glyph goes away. Not gonna be using it. Okay, so we're gonna use the same path as for the sprites. But we're not gonna be using the font atlas, so that's just normal text. Right? They're gonna be separate. Okay, so I think I figured this out then. Do I have a string drawn that's not... No. Okay, screen rects, yeah, screen rects should probably be cleared. And I guess if screen rects are like a UI specific thing, then, well, I mean, why not clear them here? Clear them here, don't draw the string on top of the... Actually, you know what? I'm gonna put it to do special glyphs to draw as sprites. Yeah, so that's an art thing, so you're gonna have to create that. But this is not how that's gonna work. So this path is not how that's gonna work. We do want to clear well, we do want to draw some text, except that let's just draw it at some arbitrary location. Is there something already there? That is not gonna happen. Okay, yeah, no, that's fine. So this is being pushed in here every time, every frame, which is probably what's gonna have to happen anyway. Okay, well, this is for later. That's also for later. What do you want to do now? I'll probably set these sprites on the ground, so they're not floating. So there has to be some notion of ground. Okay, how's that gonna work? So, yeah, okay, well, where do I even start? Okay, so this is movement. Probably before movement even. Oh, well, before movement, after, at some point, around movement. Well, actually, well, here we have this sprite. Let's just think about this one sprite. So we move it around with keys. That's animations that happens after. That's animations, that's different. So once we move it around with keys, we need to well, if it's floating, it needs to fall, for example. Like if animation frame, animation ID, well, I mean, grounded, is grounded. So it's not something like that. If it's not grounded, it needs to fall to the ground. And if it is grounded, well, actually, if it's not grounded, then we can still move it left and right. So I guess that state needs to be somewhere. Might as well put it into the sprite, why not? Boom is grounded. Arrow. And oops. Yeah, let's remove those two. And is grounded is going to be false by default, so if it's not grounded, then sprite common top left Y. I mean, right now I can move it around with up and down like that. Yeah, that's probably not something that needs to happen that way. That doesn't really make sense. Top left Y minus equals, oh, well, Y goes down and in our world space it's Y minus equals, I mean, there is no delta Y, but hello again, how is it coming along? Well, I've packed the assets into a file, and now I'm working on actually moving stuff around on the ground rather than having it floating around in space. Point 1. Okay, well there you go. So it is falling. Okay, it should probably not be walking while it's falling. Which means that this animation switch has to happen only if, okay, so it's something like this. Oops. Right. So if either of those keys is pressed, and oops, and it is grounded, there we go, then we can switch the animation. Otherwise we can't switch the animation. Okay, so it can move left and right, but it's not. Also, this flipping, well, I mean, I guess that depends on the offset. And the offset, yeah, the offset is just in the top left. Okay, well, maybe I should put a to-do in there about that. To-do. Actually, I guess it's in here, right? First frame art offset. Do we ever need an offset that's not in the top left? Because if so, that's gonna be a change here. So that makes sense. So you can control it, but it's not switching animation. Now at some point it needs to hit the ground. You'd want it for collision detection. I mean, this is collision detection, yeah. I mean, we know how big a sprite is, so it doesn't actually matter where the offset is within that. because we can always collide with whatever part of the sprite we want to collide with. At some point it needs to hit the ground. Or the order of these things is like, we kind of need to know if it's grounded before we move it around, but we also kind of well, okay, suppose this would happen here. If it's not grounded, then move it, unless it hits the ground, in which case don't move it that much. So it's somewhere we'll just have ground. Actually, what even are the positions? What's this top left Y? Oh, it starts at 0, 0. Oh yeah. In world units. Okay. So if the ground is at minus 100, let's say, if the ground is at minus 100, then this is more like new position, new Y position. Well, if the ground is flat, then that doesn't need to be any more complicated than this. And it's like, you know, if new Y position is less than the ground, then new Y position is just set to the ground. Of course, it's going to be like at the top of the sprite, whatever. Then just set it to the ground and say that the sprite is grounded. And sprite common top left Y is new Y position. Yes, it's that. Of course, where minus 100 is I think it's 400 pixels down. Which, there it is. Okay, now we can run around. Of course, it's like here. So like, it's at the top. Now being able to draw the ground would be nice. But it's not going to be defined like just randomly programmatically like this. It's going to be in the art. So what I'm thinking is we just draw a level. New. So we draw a level in here. 1000 by 1000 pixels, why not? Background transparent. These square pixels, RGBA, yeah. Okay, so that's, yeah, sure, why not? Why not? That's a 6 pixels. Okay, so that is 1 pixel. Okay. And how big is this grid? Is it like 16 pixels or something? What's this? Is there a coordinate? There is. Okay, so it's Y grows down. Okay. And this is 1000, 1000. No wait, this is 0999. 1999. Okay, so 0, 0 is in the top left here. And this is 15, so 16 pixels. This is 16 pixels. Alright, I see. I mean, what what happened? Like, okay, what if I just go into the very corner, right? And then draw a line right at the bottom. And everything else is transparent. 999. That's 0 on the right there, on the left. And what if I save this and call this like stage 1? Is it gonna save correctly? Yeah. Stage 1 is just this one black line at the bottom here. Now this will be packed in, I believe. Unless it doesn't. Invalid handle value. Okay, well, I mean, that's easy enough to figure out. Let's see. Yeah, so it tries to read the file. The file is that. Why is there an X11 in the? There's no special characters in there. Oh. 1_1. And there's an X11. Interesting. Find data. No, this is fine. What's not fine though is info names file. That has an X11 on it. And therefore path has an X11 on it. I mean, okay. Commando, Murian, stage 1_1 dot asprite, all lowercase. Alright. So far it's fine. File name. So far we're good. Oh, underscore. Oh yeah, I forgot that I used underscores. For animation names. Well, oh, that's interesting. So, and stages aren't like normal sprites. They're much bigger, and they don't have animations. So they need to be handled specially, to a degree. I mean, I suppose they will all start with a stage. There's no reason for the stages to start with anything else. I'm gonna... I need zoom it. Can I... Maybe I should just run it when Windows starts. Okay, I'm gonna go take a toilet break. Let me just mute myself. So with stages, well, it doesn't, yeah, so we do need a whole separate thing for them. So the separate thing is, well, actually, what do we need to know? I suppose in the game, we need to know what stage we're in. Or even something like extract i32 index, i32 variant, stage. Okay, so the game needs to know these two things definitely about what stage we're in, and then based on that we decide what background to load. And okay. Yeah, so stages don't really have a position, and they don't get mirrored. So, okay, so they kind of define where we are. So, perhaps they should just go to a different array altogether. They should not be packed with in the same way. I mean, the texture needs to be packed in to the atlas for sure. But that's that. Find let's see if okay. At some point I need to say, well, this is not something that we want to process in this way. Path, file, content, no, well, up to here it's fine. Well, this info, names, entity, there we go. File name, there, let's see, here. If starts, file name, stage, then do something, otherwise treat it as a normal sprite here. Okay, so what do we have in our file info? Entity, animation, file, so that's names. That is the content. Well, bool is stage. We have to set that. Oops. Info is stage. Well, I suppose I can set it to just this, contents of this, like that. So if is stage, then actually if it's not stage, then just do this. Entity, animation, file, names. I mean this names thing, that only applies to the entities, like normal sprites, not stages. So maybe I should rename it. Is this possible? Or entity names, file. I mean, I suppose file name isn't gonna change. So that part is fine. Well, what do we want to know about the stage? We want to know index and variant. So we still need to pull some things out. Okay, yeah, we do. Else. So for stages it's something, for non-stages it's something else. So for stages, again, we do want to go through all of this. And then whenever we well, actually it's not even like that. It's like str name. It's like numbers. Would be str slice file name, and this would be, can I actually do this? Str stage lang. Yeah, so slice from here to the end, pretty much. So file name length, like that. So these are the numbers, so that will leave us with 1_1. And now we can go through, find that underscore, and just say str index str and variant str. So if we found an underscore, that means index str is str slice file name. Let's have to break at the end of that. So slice the file name, so basically split it. So from 0, well, not file name, well, numbers. There. Okay, we go through numbers, but once we find an underscore, index str is str slice numbers from 0 to this index. And variant is everything that's after that. Variant str slice from index +1 to numbers. Okay. And bool found is true. Not bool found is false. Found is false. Found is true. Break. Okay, so assert found down here. And now we need to get actual numbers out of these things. So, which are not null terminated or anything. Is it like A to I or something? Counts char star, so that expects an all-terminated string. Okay, well, never mind. Is there an A to I with like an N in it? No? Doesn't look like it. Okay, well, we want U64, let's say, index, well, U64, well, I64. Index number is parse int, I suppose, parse int. Index string, well, even parse uint, we know it's positive. U64, index number, and the other is variant. Okay, so we parse them out. Now we have them, so we can store them in info stage. Index is, well, cast to I32 index number and variant. Okay, so now they can be stored. So we're still not doing anything with that information, but at least we're pulling that out. Path, content, and so on. Okay, well, sorting them. Yeah, maybe it should be a separate file info. And it's almost the same. Well, it's almost the same, but also very different at the same time. So maybe I should have two of these, actually. File infos, entities. This is stages. And yeah, so all of these file infos, file info entity, and there's going to be another one, which is type def struct file info stage, which is this index variant and just file content. Okay, so this is stage. Yeah. Okay, assert current file index is less than. Okay, do we even need that? Yes. I mean, apparently. That's kind of a. Why don't we? Well, I mean, if we could do it this way, why not? Well, actually, now there is a reason not to do it this way. File info entity info is empty. Okay, so info arrow is now. Oops. Info dot, and at the end here we need to push it in. Push file infos entities info, like that. Okay, so this file info comp is actually file info entity comp. Is stage is bool, it's kind of its own thing. Yeah, okay. Alright, so what we're gonna do then is something like this. So read it in, set the content. Yeah, okay. It kind of needs to happen like this. And this extra one is not necessary. There. Okay. Str file path content asprite, and this is gonna happen in both cases. Well, even like content equals ace there. If is stage file info stages, yeah, like that. So initialize the content immediately. Oops, what? Oh, I can do that. Interesting. Okay, index variant. I suppose just move these here. That's not necessary, right? File full, I guess. And then this file name is file. Yeah, well, why not? Yeah, just leave it at that, I suppose. Alright. I think that works. In that, we're not gonna break existing stuff. Well, we can even do it this way, right? Yeah, because it's only really created here. Oh, yeah, move it up. Okay. Infos stages. Okay, so push this in to stages. Parse event is not implemented yet. What's in here? Oh yeah, that's the assertion failure. It's fine. Okay, well, everywhere we use file infos, that's really just file infos entities. Okay, now it's just parse event. It's not implemented. Well, it's implemented real quick. Static void, static u64 parse uint. Str. Right. Yeah. It's gonna have to iterate through the string. pull out the characters and look at the characters. Assert char is less than or equal to 9, and char is greater than or equal to 0. And so if it's 100, so initially I guess we kind of want to go backwards. Is greater or equal to 0. Like if we see a 5, then that's plus 5. The result is 0. That's the char. That's U64 char number is char minus 0 and then it's result plus equals char number scaled, and U64 char number scaled is char number times scale, and the scale starts at 1 and then it goes up by 10. It's like we're going backwards, right? So index should actually be minus minus. Yeah, so pull it out. Assert minus 0, so it's 9 is 9, 0 is 0. Multiply with the current scale, which is 1, then 10, then 100, and add that to the result. So yeah, I think that makes sense. Okay, there are some errors. That happened. Interesting. So why did we reorganize all of a sudden? Commando idle used to be the first, and now it's the last. Yeah, so something weird's going on with like the file name, seemingly. We're just not setting it or something. So we want names for entity, animation, and file. And I think we're just not setting it. In the build program. Yes, info, yeah. Names, file is file name. Oh wait, that's the wrong one. It's actually down here. Entity, right, is that it? What's the, it's like right side, active editor, active edit, focus other side, yeah. Names, file. Okay, so it's this line. No, it's just the whole file name. file full. Okay, now generated is the same as expected. Now, of course, these stages. Maybe I should, like, while we're here, just assert real quick that parse uint 1234 equals 1234. Oops. Yeah. And I don't know. Yeah, it seems to be parsing fine. Okay. What do we do about the stages? Well, what does the game want, I suppose, is the question. At some point we do need to, like, be able to update what stage we're in. At some point. Probably not. Okay, so this is the update, right? Well, maybe I should mark it. At some point the update needs to happen, but that's for later. For now, given the current level, well, actually, we're not going to be updating the current level, and like movement and stuff. Well, we want to know what to collide against, so in that sense we do want to know what the level is. But other than knowing what the level is, well, actually, at this point, we know where the sprite is, and we know what level we are in. So the information that we want out of the level is what are we colliding with. And then just collide against everything that we could collide with. Yeah, okay. What's that gonna look like? I mean, I suppose in this game there is no oblique lines. It's all, everything's axis aligned. So really the things that we're colliding with is a set of vertical lines and a set of horizontal lines. And that's it, pretty much. And like if we are grounded, we can only really collide with a vertical. And if we are not grounded, I think we can collide with any of them. And most of the time you're probably gonna, well, not most of the time. Sometimes you're gonna be grounded and sometimes you're not gonna be grounded. But either way, yeah, I mean, you do jump around a lot, so really it's really for each line we just need to know if it's vertical or horizontal and kind of where it starts and where it ends. Start, end, and orientation. And whether a sprite is grounded is gonna affect it like a little bit. So what is it, like collision line? Yeah, so for each, so we're gonna have to go through collision lines and collide with each of them separately. go through the relevant collision lines given the current level and collide with them. So that's gonna have to happen here. So that's not something that's relevant to us right now. Neither is this. Okay. So this part is the relevant part. Alright. Let me just go to common then. And collision line. F32 start end and like bool horizontal. And we don't need to know anything else about collision lines. We don't need these to be two-dimensional because we know it's all axis aligned. Alright. And these collision lines are gonna have to be in well, in the assets. We know what they are in one sense, in the assets. Like here, in the same sort of way that we have these atlas locations, we could just have a bunch of collision lines. Just in here. Which means that we want to pull them out of the source art and pack them into the assets. But let's just like pretend that we've done that. Temp collision lines. Just pretend that we've done that. And just have one line here that's like, that starts at, well, in our world we are presumably bottom up, right? And, well, right now we are at 0, 0, the camera is at 0, 0 and everything. So let's say our temp collision line is located at, it's a horizontal one, right? It's a horizontal line, and it goes from -1000 on the x. Well, hold on. Now we also need to know the other one, right? It's length. Yeah, it's not start end. It's where it starts and how long it is. There we go. Where it starts, well, for horizontal ones it would be left, but for vertical ones it would be top, I guess, or bottom, either way. And F32 length. So we need to know if it's horizontal, we need to know where it starts, and we need to know how long it is. Yeah. So start is, oh, not start, left. Left, so it's horizontal. Left is at like -1000, whatever, that works. Right is at 1000, let's say, or maybe like, let's do, yeah, let's maybe do that, -1010. you know, let's do something. And, you know, left and how long it is. Actually, this is the starting point, right? Well, hold on. What if I do 0, 0 for now? And how long it is? Let's say it's 10 world units long. Len works for me. Come on. Alright. No. I should be inside. Something like this. Okay, it's not being used. Wait, are we still running? We are still running, yeah. So I kind of want to draw it so I can see the collision line, irrespective of whether we have the art for it. And we do have that white pixel, so I mean, we should be capable of doing this. Let's see. So 10 collision lines is that's fine. Well, actually, if we all our sprites, no, that's fine. That's fine. Okay, collision line is that, ground. Okay, this code is kind of temporary, but yeah, let's keep it around. We know we're gonna have to iterate through them. So like I32 collision line index is 0, collision line index is less than array count temp collision lines collision line index plus. Okay, so collision line, this is not temp. Like, at some point we're gonna have to do this. Is that, there we go. And signed integers, whatever. Okay, so there's the collision line, right? And only collide against it given some test position, given the current position and the new position. Because if we are stationary, we don't really need to collide with anything. Collision is only relevant if we are moving. I guess this is just straight up new position, or test position. Test position is just the current position. Yeah, so for now let's just collide with the reference point on the sprite. If it's not grounded, then test position y, we subtract this. There you go. Well, I mean, presumably, like, if test position v2 eq test position current position, like if we moved, then we need to collide. Otherwise we don't need to collide. Where's my V2? V1, V2, V2. Return V1, oh my god. V1x equals V2x and V1y equals V2y. So if they're not equal, then collide. Now, I guess that makes sense. I mean, let's just do current position. That test position is just copy that current position. Okay, now we have current and test. Which I guess this equals isn't that necessary. So given the two positions, we have that sort of change between them. And that change is the thing that needs to be clipped to the nearest collision line. So what's the change? V2 delta is V2 sub current test position current position. Okay, well that's the test delta, I guess. So if we are unimpeded, then we'll go by that much. So if the current is at 0 and the test is at 5, then test delta will be 5. And the test delta needs to be clipped. So really we don't need this equality, because if test delta is 0, then it's 0, right? So we just do sprite common top left equals V2 add sprite common top left test, well, I suppose it's not really a test delta then, it's just a delta. There. And that's the collision process. Okay. Okay, well let's draw the line somehow. Can we draw the line? Well, we kind of want to draw it as a sprite. And the sprites and presumably these stem collision lines should reside implement get from art, get from assets. Let's just put them here. Or like up top maybe even. Okay, so implement that, and so that will be collision. Wait. Static bool. Okay, unused variable. Yeah, that's expected. What's the other thing? Oh, no, it's the same. Okay, well, unused variables, whatever. Leave it there. And draw the line. Copy sprites. Yeah, well, I mean... So this is where we're actually copying these sprite tracts. And this is where I'm going through the sprites. And I guess if I want to draw collision lines, I would have to do it here. I just have to go through the collision lines and draw them. Do I have that in there now? Well, yeah. Let's just see what that looks like. Okay, so that's that. And then there's the collision lines. Yeah, so sprite rectangles can be... I mean, they can be actual sprites, or maybe they can be something else. Temp. Okay, so go through and... So this is the process. We don't really need this, because we already have the collision lines, so there we go. Well, it's not sprite rects plus sprite index, it's actually sprite rects. We're going after game sprites, right? So it's like to go to the end and then go to the collision line index. Yeah, okay. Okay, common. So we do want to fill common with something. And what's the common? Or is it sprite common? Whether it's mirrored and top left. Okay, well, top left we kind of know. Collision line. Well, either bottom or left will do the job. Yeah, sprite rect. Text in Atlas. So we're not passing colors here, interesting. We're not passing colors. So it's just gonna be white. Well, I mean, yeah. Asset, game, assets, Atlas, locations, Atlas, Atlas ID, white pixel. Let's just see. Is that even going to do anything? No, I don't see any lines drawn anywhere. Oh wait. Unless it's like a singular pixel, because we're not stretching these. Do we want it drawn this way? Do we want it drawn another way? Because really this is, well, this is a solid rectangle. What I expect is a solid rectangle. The only problem is that solid rectangles expect pixels as input and not... I mean, we could have another pipe just for the solid rectangle, but that doesn't really make sense. Okay. All right. So it's not gonna happen here. It's not gonna happen here. It's gonna happen elsewhere. Probably here, actually. Yeah. So as a temp measure, let's go through the collision lines and push them into these screen rects. So that's not what's happening. rpush game screen rects collision screen. Okay, screen rect collision screen is, well, we do know what the Texan Atlas is, and we do kind of know what the color is right away. Yeah, we just need to figure out the rectangle. Okay, collision line. Well, collision line has that left and or bottom. So I guess just figure out what the camera space rectangle is. So it's only got one position. So V2 pause camera is V2 sub collision line left, and we're subtracting camera position game camera position. Okay, position in camera space is that, then position in so that's in world units, right? And then we just kind of need to multiply by the V2 pause pixels from center is V2 scale pause camera, oh my god, what? Pause camera scale by game sprite scale multiplier. And then we just pause screen is V2 add this, and we want to add what, half dimension window half dim. Yeah, that should probably just be a procedure, just in case. V2 window half dim is window width, window height. I just divide those by 2. Okay, so that's the position. And it's basically just the top left, right? And as for dimensions, well, if it's a horizontal line, then the x dimension is just the width. Length times that. Um, and the y would be just the thickness, like 5 or something. And then if horizontal collision line F32 thickness is 5, horizontal, yeah, so if it's horizontal then that, otherwise it's just, those are swapped around. Okay. Skr is pos skr dim. I think that works. Use the variable collision line. Okay, there it is. Alright, that's something. Okay, so that's going through screen rectangles. I mean, this is also a temp thing. Okay, so now I can move it somewhere where it makes more sense for it to be. So let's make it bigger. Let's make the left be minus 10 and the right be, no, the left be minus 10, yeah. And the right be minus, I mean, these are, interesting. Well, these are meant to be, like if we go back to 0, 0 real quick. Why is it suddenly not in the center? Position screen 0, 0. Offset from center 0. Position camera space 0. Position camera 0. 0, 0. Yeah. So those are the dimensions, and it's here, not here. That's weird. Okay, so there's something probably incorrect with our drawing of the of them. I'm gonna go take another toilet break. Mute. what's wrong with our lines? Let's find out. Well, yes, this is definitely not drawn where it's supposed to be drawn. Now, okay, so let's just remove that, so there's only one screen rectangle being drawn. Let's go. Right, so that's, the sprites go first, right? And that's this, yeah. Mesh viewer. Okay, what goes in even? Top left, 1280, 720. Yes, that is correct. That is halfway through the screen. I mean, that's 0, 0. Which is correct. I mean, wait, hold, is it in the center? Like, what? Am I just off in my understanding of where the center of the screen is? No. No, this is not in the center. Well, this looks like it's in the center. But then it's just like off. Wait a half of it is not drawn because it includes the transparent layer. Of course. So white pixel should probably not include the transparent layer around it. And neither should the glyphs. Maybe? Well, definitely the white pixel. I don't know about the glyphs. Glyphs, we're not blending them. And with these solid rectangles especially, I kind of want them to be precisely where I put them. Yeah, given that we're not blending them, the actual textures should probably correspond to... Although, we seem to be drawing the string fine, right? In terms of spacing. Yeah, that looks fine in terms of spacing. Okay, so that white pixel texture. Do you pack it in differently? Yeah. Width, height, push. So we do want the border around. We do want the border, but only sometimes. So there's the atlas locations. Okay, so there's the atlas. Alright. So we take what we have and we put a border, transparent border around everything. And then in the locations we refer to that. Well, I suppose for locations we can be consistent and just leave it as is. But then go into the like go in here and just say, well, like essentially shrink by 1. Right? So like that would be rect white pixel is that, and the white pixel dim is v dim x minus equals 2, dim y minus equals 2, and the white pixel top left x plus equals 1, and top left y plus equals 1. So that would be a shrink by 1. Oops. There. Okay, there it is. Now we see the whole thing as I drew it. Okay, let's put it to do here. All locations in the atlas have a transparent border around them. Should they? Let's think about that. Okay, so there's the collision line. Alright, it's horizontal. There's the left, there's the right. So let's move it to the left. A little bit. And probably down. It's moving up. Oh yeah. Position camera. The y up versus y down thing, man. Position in camera space is -40, so pixels from center is actually plus 100. Pause pixel from center. Y prop. Excuse me. -1. Okay, there it is. Now it's down. It's moving down. It's moved down. Alright. Well, while we're here, let's see. We expect the top left to be minus this is 176. When do you have them? Oh, it's the first one. Okay, let's let it run. There. Okay, so 1328 1. No, that's text endless, hold on. 840, 896. What's this? Yeah, 840, 896. Okay. Alright, so I draw it in the right place at least. Good for us. So now we know where the collision line is. Visually. So this movement delta needs to be clipped to that. Somehow. How do we do that? Well, for the collision line, like if horizontal, so if it's horizontal, like it's pretty simple, right? Because it's axis aligned. If it's a horizontal collision line, that means that only the vertical component of the vector needs to be clipped. Let's see. So we have a line that we're colliding with, and we have a vector that is colliding with it. It's like starting position, ending position, and this vector has. I mean, I suppose it should be an arrow, right? That is one giant arrowhead. Gigantic arrowhead. Yeah, so that's got a component, right? And another component here. Okay, and this, if that's the collision line and that's our delta vector, then we need to clip it to this and then set because it's a horizontal line, we need to set the sprite to be grounded. Kind of already know everything we want to know. This is just the y, this is just the x of the delta. see if I can remember some of this. Pick any point and there's another movement. This one would not need to be clipped. Okay, yeah, we know when it crosses it. Although because it's a horizontal line, we kind of know if it crosses it simply by subtracting. Like if we take this x minus this line and this x minus this line, if those two signs are the same, then it doesn't cross it. And if the signs are different, then it does cross it. Of course, for the case where the signs are different, where it crosses it, it's just like, well, we know this difference, and you know this difference. So you kind of know the proportion. And at that point, once you know the proportion, you can just multiply by that, right? And for this case, it would be, well, this and this would be the differences. They have the same sign, both of them. So, well, I mean, this would be the answer, right? It's like, the answer would be whatever you need to multiply this by to make it like touch the line. Presumably. And in this case, the proportion is just like, let's say this divided by that. So the difference from divided by the whole x component. And here it would be the difference from divided by the whole x component, and that would actually be greater than 1. So it just works kind of either way. So just thinking about horizontal lines then. So this is the x component of the delta. So x component of the delta, or even, I mean, delta, sure, but we also have a current position and a test position. So current position y minus line y, position y minus collision line. Well, left is the so it's horizontal, it's left, right? Minus collision line left y. Yeah. So we have this point and we have that point's y coordinates, so we can subtract them to get this number. Current to line is that. Test to line is something else. I mean, it's the same, right? It's test position y minus so So that would be this number, and if they have different sides, then we know it crosses it. But and I mean, at the end of the day, we kind of want to figure out what to scale this by, right? It's like we're not necessarily going to change the direction there. And I mean, we could also like redirect it or whatever, you know. But maybe do we need that really? I don't know. Maybe we don't so much. Although we'll find out. So for now we just have start, end, and this divided by the whole x component would be not x component, vertical component. Test to line. So F32 prop would be current to line. That's this divided by delta x, delta y. As in this minus that, delta y. There. So that's the proportion. And for now, I guess we just kind of need to find the smallest proportion. So let's say prop is what, 1.0, and this is like test prop. Prop is min, prop, test prop. V2 clipped delta is V2 scale delta prop. So that. Where did it go? Okay. It disappeared. Minus 400. Well, oh yeah, negative numbers. Negative numbers. So the current to line is 40 and delta y is like negative, right? So what is this? Current position 0, test position is minus 0.01. It's actually just straight vertical like that. 0 minus 0.01. And collision line, oh yeah, also collision, this is not, get from assets, and also position, like this is just the position in world space, right? So not necessarily in camera space, and although that, I mean, we can handle that right here. Right, so we can just say that is the collision line, V2 collision ref is V2 sub collision line left camera game camera position. Yeah, so collision line There we go. Now the collision is in camera space. At least. So, and except that it shouldn't be. No, it shouldn't be, because the sprites are in world space, and they are in the same coordinate system. Right, so that part's fine. They're in the same coordinate system. Hold on. Get back. Yeah, collision left. Yeah, there we go. Okay, so it disappears somewhere, and because we're not handling negative numbers correctly. Okay, what's this again? 0 and current position is 0, and this position is negative 0.1. It's like 0, negative 0.1. Collision line is minus 100 minus 40 in like world space. So like minus 100 and minus 40, so like here is a 0, 0.1, minus 100 minus 40, that's this line. Current to line is 40, so I just did current position 0 minus this distance. And delta is minus 0.1. That's this. And test proportion is this divided by that, 400. So it ended up being minus 400. Whereas really it should be 400. Like, as in if you scale it up by 400, then you'll reach the ground. You definitely need to handle the signs correctly. This is in the same direction as right, this should probably be current to line. So if y goes up and you want this to be, I mean, it could also be like it's pointing the other way, right? So either way, and wait, does this even make sense? Well, then it would be negative. No, there will definitely be a situation where it's negative, which means you need to go the other way. So normally a negative number here would mean you need to reverse and then stretch to get here. You need to reverse and then stretch to reach the ground. So we shouldn't be getting negative numbers here. So if we're doing this minus ground and this is 0 and this is minus 40, then this it will be a negative number. So we really should be doing this, the bigger number minus the smaller. Actually, bigger minus smaller is what's happening. 0 minus 40. So that's 40. It's really the delta. That's delta. I mean, no, y does decrease. Y does decrease, but in this case we actually want this minus, what do we, that's the god. Well, no, we did this minus ground, right? So by the same token, if it's this minus ground, then it should be this minus that, to make the signs make sense. So it's not really a delta y situation. Yeah, so really it should be, alright, clipped delta is actually more like a V2F lerp from current position to test position by prop. So probably don't have a lerp. Yeah, we don't have a lerp. Current to line, F32 current to test is current pause y minus test pause y. Yeah, so now the signs will at least make sense here, and now we need to add the lerp. Okay, so that one's a V2, and it's gonna do V2 lerp f, I guess, lerp, whatever, lerp v1 x v2 x y and lerp v1 y v2 y y. That. So presumably I don't have a lerp. Yeah, I don't. Static f32 lerp f32 from f32 to f32 by return from times by plus 2 times 1 minus pi. So if by is 0, then it's all, it should be the opposite of that. If y is 0, it should be from. There. Does that compile? Yeah, so that compiles at least. Okay, now let's see. So test proportion is 400. So now it makes sense. It's current to line is 40, current to test is 0.1. So the signs are the same. Of course, we will still have a situation where they are reversed. And it still disappears. Test prop is 400. Prop is 1. Yeah. So clipped delta. Oh wait. New position. There. Okay, so this should presumably stop it. Yeah. So it still doesn't work all that well, because the signs can be the same, can be different. And if the signs are different, then we definitely don't want to accept that. So, like, only do this when the sign is positive or something? Like, if test prop is greater or equal to 0, then do this, like that? I mean, I guess. Let's just add another collision line. But this one is gonna be like here. Oops. Am I not allowed a comma there? Come on. Okay, Well, it seems to be not crashing at least, so that's something. I do want to be able to move up and down, though. Up, down, forget about mirroring, Y. Okay. What? Now it's not? No, because there's overriding it or something. Oh yeah. Input. So I'm only colliding with like the sort of natural movement downward. I need to be colliding against, okay, so it's like right here. This transports, the sprite is that, sprite is that, sprite is that. Okay, off. So move this here. So all the updates actually only happen to the test position. Okay, there we go. So this should probably happen after here. Yeah. Okay, so there's the delta, there's the sprite. Just updating one sprite for now. Set the animation to idle, although that should probably be like here. We set the animation to idle. Like it's really like that, right? So it's walking, unless it's not walking, sort of thing. Okay, there's the current position, there's the test position, and it's the test position that gets updated. Mirroring, yeah, mirroring needs to happen like outside of this as well. So if left is down, then mirror x is true. If right is down, mirror x is false. Otherwise, don't touch it. Just leave it as whatever it is. Okay, so that's mirroring, that's animations, and then we do some animation updates later. Okay, times ms since last update. Okay, now let's not think about grounded too much. And just do the animations just from the movement. Let's see, so alright, so if up is down, then we are increasing. If down is down, then we are decreasing. Yeah. And let's increase our delta x. Yeah, okay. Interesting. Okay, well, we can't move down because we just got stuck to the thing. It's not because we are grounded, it's presumably because of this, like, let's see, actually. Huh. Interesting. Huh. Well, it's not really what you'd expect. So it literally is just 0, huh? And then once it's 0, you kind of stick to that wall and you can't move down. And presumably you can't move down because current to line. Well, let's see what happens there. Oh my god. It's like if you're right on the line and you're trying to move down, then current to line would be 0, and immediately current to test, no matter what, like current to test is not 0, but test drop is 0. I mean, this is kind of weird. It should probably not be working like that. Like, what's happening here exactly? Why are we just zooming through that? Test prop is greater than 0. Current to line, current to test. I mean, presumably there should be a situation where we are here. So current to line is like negative, and current to test is also negative, and proportion current to line divided by current to test should be something that's greater than 0, you'd think. And yet it isn't. That is strange. Huh. The line, I mean, the updates are happening in small increments and stuff, but like, so what? Let's see, so if I just move up here, and okay, so like right now test proportion is infinite. Current to test is z. Oh yeah, because it's not moving. Oh yeah. Well, that works. You know, that works. Prop is one. Okay, so how do I even debug this? It's like if current to test is greater than is not 0, um, debug break, right? Debug. I can assert whatever break. Okay, there's the assert, triggers, yeah. And actually I think it'll like keep moving or something. I don't see it. Okay, well it moved off somewhere. Okay, let's try that again. Okay, there it is. And like on the next frame, but it's still there. Okay, oh, and now it just moved way up. Oh, because of the time between the current to line 80, current to test minus 90. Test position is 130, current position is 40. Okay. New position, prop is 1. 130, 40. Really? Okay, there's something weird going on here, for sure. Why? Why? Because it just zoomed through that. Even though that doesn't really make sense. Why would it do that? No, presumably when prop is 0, it should just never change the position. Let's verify that. Yeah, let's remove this. Yeah, so there it is. It's not changing the position ever. And it couldn't be greater than 0, 1, you'd think. I mean, if I make this really large, it shouldn't matter. But it does. Alright, well let's find out. I mean, that shouldn't be happening, even again. Maybe it is because of this. Hold on, is it? It is. Because we end up being right on the line, and as a result we can't move anywhere. Okay, so all of these are just symptoms of the same problem. When you are right on the line, you can't move. So if we just solve that, then, you know, we solve all the rest of it. Okay, what are we supposed to do about that situation? To get you here. And you want to move somewhere. Well, I suppose if instead of like clipping the vector, you so you say, okay, 0.5 is where we clip it, but then we want to move. Actually, do we? I mean, we could bounce or move along, but what's gonna happen in this case? We're moving right, like we're moving out. Like if you're moving away, that seems like it's a different thing than moving into. Well, that's the problem, right? Is that this is right on, so it's not on either side. It's not like crossing it, and it's not crossing it. It's starting right on it, and then it's moving. Oh my god. And what are we doing? Oh my god, there's two of these. Why? Why? Can I remove one of those? Edit line. Oh. All sorts of weird stuff goes on here. Huh. Interesting. Can I remove a node? Exit line editor. Apparently not. I mean, I can remove the whole thing. I can do that. Alright, so clicking here kind of adds it or something. Yeah, it does. Alright. Okay, so what is this nonsense? Like, you're inside the line, the collision line, and you want to move away from it, away from where it is. Well, fundamentally, like, if you're right inside the line, you can't distinguish between moving away and moving through. Yeah, because if this line is supposed to block you from moving, oh god, from moving down, then once you find yourself inside of it, the line itself has no direction. So it kind of makes sense that it would stop you from going either way, because it's bi-directional like that. So we either need to add information about what side it's supposed to be blocking, and then if you're moving towards that side, only then do you need to be clipped. Or do something that requires less weird special casing. I don't know, is there something that requires less weird special casing? Maybe. Well, the idea that I just had would be something like, if collision line is horizontal and current to test has the same sign, like it's on the same side of 0 as the whatever direction is attached to the line, well, not even current test, current to test. It's like if we attach information onto the line about what it's blocking. Let's say let's say this is the line, and this is like, well, really it's one bit of information. It's like where you're blocking movement from. Then any vector that looks like this would be clipped potentially, and any vector that looks like this would not be clipped. So you would be able to move through this line from the other side like that. Which, when it comes to like platforms and stuff, this is exactly how they work. So these lines kind of do need to carry information about directionality. Okay. So it's not just horizontal, vertical. It's horizontal or vertical. Well, really, it's like block from top, block from right, and block from, yeah. It's that sort of thing. And potentially they can do multiple. Although, is there any? I mean, you'll just have 2 lines presumably if you want to do multiple. Yeah, because no wall is gonna be less than 1 pixel, presumably. Yeah, so alright. So come on. Alright, so this is not horizontal, this is actually collision line type, and this is a whole thing. So we got block from top, bottom, left, right. That's what it is. Alright. So we have these 2 walls. Type is so the one that's below blocks from top. The one that's above blocks from the bottom. Block from bottom. What's the problem? No, I did not mean block from top, actually. I meant block from bottom. That one. Yeah. Can you catch up to me? No. Okay, right, never mind. Okay, the one that's below blocks from top, the one that's above blocks from bottom. And the way we would have to handle that is like, if collision line block type if it's blocked from bottom of the movement, okay, what does that even look like? That looks like this. Okay, so anything with a positive, with a y up, right? Anything with a positive y needs to be blocked. And positive y on specifically, if you take, what do you take? Test pos y is greater than, that's a lot of if statements. But I'll just write them out individually for now, and we'll see. We'll see if that collapses. So it's like if current y, I mean if you're gonna, current to line and current to test. Okay, well, if we work out current to test, this is current to line, this is current to test. If current to test, this is bigger, this is negative, it's like that. Oh my god. Specifically negative, I guess? Like specifically smaller than 0. Then do this. Actually, it's like that, right? There. Yeah, if it specifically blocks from the bottom of the movement, then current to test should be negative. Because y grows up, so current to test is negative. And then like else if it blocks from top, then it's that. But like this is different. Now it's positive. So blocks from top would be something like that. So it should block all of these. So current to test is positive because this is bigger number. Oh yeah, we also need to be able to draw these things. Type is collision line type block from bottom or block from top. So block from bottom, block from top. Really, that's the okay. Okay, well, I mean that does work kind of. You still can't move diagonally; you just get stuck. Not that that's necessarily a problem in this game, because you're not going to be moving up and down like that anyway. Alright. Well, obviously this is not ideal. Like it's exactly the same except for this sign. if I keep going here, and well, actually, maybe I should collapse these two. Or, let's actually do the others. The other two types. Block from left. Block from right. Bottom, was it? Okay, bottom. Okay, minus 140, so the bottom should be in the bottom left, so like minus 40 on the Y for both of them, but this should be like block from left should be on the left, and block from left should be on the right, and block from right should be on the left. And of course we're just gonna crash right here. But let's see. Else if block from left, else if, so this should be block from right, well actually, hold on, let's handle left first. Yeah, with left we've got, so instead of dot y, it should be dot x. Okay, and then this is the test proportion. And if you're blocking from left, then current to line should be less than 0. Because current should be smaller, so it's a negative number. That would block from left. And block from right is exactly the same, but that sign is different. This sign is different. Okay, interesting. So those lines seem to be being drawn incorrectly. Yes, we've got collision, dimension, position. Yeah. So that's the bottom of the line. Maybe it should just be the top instead of the bottom. Maybe it should just be the top, because every rectangles are defined in terms of top left. Oops. So let's just make it be top, and then length just would go down. Yeah, they're still very big, but I think that's intent. Yeah, that actually does make sense that they're that big. Okay, we are colliding. So that's something at least. Now, The fact that you get stuck like this kind of is a problem though, because like if you wanna jump against a wall, you don't want that wall to catch you like that. Yeah, that's not good. You also probably don't want to bounce, you just want to go like up against it. So that's the, yeah, well, I'm gonna put it to do in here. Well, I think there's a lot of things. First of all, can we make this be less bad? Let's see. Well, this is exactly the same, right, for the first two. And actually, this really tells us which field to pull from both positions, like which are the relevant fields. Yeah. Okay, so if or so if it's block from bottom, block from top, that means it's horizontal, and when it's horizontal the relevant position is Y, otherwise the relevant position is X. So 2 I32 rel index is 0. I mean, it's kind of just this, right? Like it's 0, but if these things are true, make it explicit. So if it's block from bottom or block from top, then the relevant index is 1, because it's the Y index. F32 current is, I mean it's this, it's current pause whatever, right? Current F32 collision and F32 test. And current pause, and I kind of just want to do rel index like that, except that I can't do it this way. But I can if I just cast it, right? Collision, so it's the same for all of them, except that this is collision line left. Well, it's left or bottom. It doesn't really. Actually, either way, it's top left, isn't it? I mean, there's no real top left, I suppose, for a collision line because it's like infinitely thin. So, like a reference position, let's say. It's also possible to misalign, right? So in this form, we're kind of assuming that they're all infinitely large. change this first. Like at no point am I using the fact that there's a length, there's a limited length. And yeah, I'm only using the position. Okay, so this is alright. And then we just do this. Well, actually, we do this first. Okay, so this is current minus line minus collision. This is current minus test. And this doesn't change. This is just test, current to test. Okay, now this thing needs to change. And really the only thing that changes is the sign. I mean, we'll need to clip. If we make it explicit, it would be something like this. So it's less than 0 for bottom and left. Okay, so that's kind of what we have right now. Oh, well, let's see. Do any of them work? One of them is probably incorrect. Test. Yeah, that works, that works, that works, that works. Alright. Okay, all these lines are infinitely large, so that's kind of a problem. But other than that, this is a start. I'm gonna go take another break. Mute. Okay. So is there a simple way to just handle this case? Like when we're moving next to the line? Because right now, we're not really doing that. Let's see. So if I just reduce these lengths to like 20. Interesting. I mean that works kind of, right? So like right here. So that line is, even though it's small, it's still blocking us. Incorrectly. Because at no point do we account for its length. Okay, current position, test position, I mean, it's like, well, when the intersection point is within the line, then you clipped. If it's not within the line, then you haven't, essentially. I guess that would be it. Maybe. Maybe. I mean, I guess I can leave this comment out. Handle grounding. Grounding. Handle grounding. Make walls not sticky. That's another one. And well, and what I'm trying to do now actually is neither of those. It's this. So, well, okay. So given that we worked out the proportion, I guess what I would need to do is like say, well, if we interpolate up to here, is that still within the bounds of the line? So prop F32 clipped position would be like, it would be something like lerp current to test by prop, something like that, right? So like actually it's not, it's the other one, right? Because current, like we were looking at why, now we need to be looking at the other one. Okay. I mean, at this point I'm thinking maybe there is a better way. Hold on. Let's put it to do here. Is there a better way to do line? I mean, it's essentially a line segment. It's not a line, it's a line segment. Line segment collision. Okay. Okay, this is the other one. This is like rel index. Well, other index is rel index plus 1 mod 2. Okay, this is all sorts of weird. Other index, F32, and in clipped position is like, oh my god. It's like we want to clip from, like, from here to here. Okay, this is really by that proportion that we just worked out, and now we want to check F32 test proportion. Oh fuck. Test prop 2. Okay, this is really not great. Is the minimum there? Actually, it's not even that. It's like if test proportion is greater than equal to 0 and test proportion is less than proportion, if it's greater or equal to 0 and it's less than proportion, then at the end of this whole process we would accept it, like prop equals test prop, like that. Okay, so this is by test prop, right? So clipped position is now the clipped position along the other axis is that, and then if this is within bounds, if clipped position is greater or equal to collision bound 1 and clipped position is less than or equal to collision bound 2, then you accept the proportion. Okay, so yeah, I'm guessing all of this can be expressed differently somehow. Okay, what are these collision bound 1 and 2? F32 collision bound 1 would be, well, if it's left right, then it's just left, right? So it's just this call. Collision bound 2 is collision plus, I mean, clipped position, so it needs to be within the bounds. Well, it's call plus collision line length. So it's something like this. And for left right, this just works. For top bottom, I mean for left right, for horizontal lines it works. For vertical lines, our reference point is in the top, and y grows the other way, so we actually need to subtract. If call bound 1 is greater than call bound 2, then just switch these around. Call bound 1 is call bound 2, and call bound 1 is call swap them. Okay, well now you're not colliding against anything. Interesting. Okay, well, we know that this is the only code that's been added. Call bound 1 should be smaller, and clipped position should be between. From current to test by that. And this is the other index that we are considering. Collision plus collision line length. Oh, it's not col, this one. It's the other. Like we're looking at y, now we need to be looking at x. F other col. Yeah, man, this is really not great, huh? So all this is other col. Okay, now you can. All right. Okay, well, for some reason we are not. Oh yeah, because we are clipping with like the top left or something. Okay, so this is approximately what needs to be happening. Oh yeah, we're mirroring the sprite, so yeah. All right, so and of course we need to collide with more than just a point on S for right. Okay, all sorts of things we need to do. Okay, but this is kind of working. Maybe I don't know what's going on with this wall. I mean, it only works sometimes. Yeah, it's like we're colliding with the bottom or something. Like that's weird. Yeah, definitely colliding with the top here. And are we colliding with the bottom? Yeah, we are. Okay, it only stops us like sometimes. Am I even drawing them in the right places? I don't be drawing them in the right places. Oh yeah. So dimensions don't change, but like bool horizontal. Bool horizontal is that. And if horizontal then y needs to be moved. I mean, at this point we're in pixels, so it needs to be moved up by the dimension. Okay, so this is horizontal, right? Horizontal. let's just set the dimension to whatever it would be for vertical, so x, y. But then if it's horizontal, oh wait, no, the other way. It's something like this. It's so that position works for a horizontal wall, and that dimension works for a horizontal wall. Yeah. And so if it's not horizontal, then it is vertical. So if it's vertical, then dimensions are the other way. Thickness on the x and the longer one on the y. And position from center y, position screen at this point, really. Position screen y needs to be moved up by dimension y. Because that's the... Wait, does it? No, it's meant to be the top, isn't it? It's meant to be the top. So we don't actually need to do that. But yeah, it's meant to be the top of the line. So actually we were drawing it fine. Wait, hold on, if we're drawing it fine, because it's the top of the line, then are the dimensions just wrong? I mean, hold on. Then why aren't we colliding here, but instead colliding here at the top? Here. Like, that's fine. That's fine. But in terms of like where it's drawn corresponds to where it is. But that other line, it just isn't. Top. Okay, 140. That's the block from left. And I moved it to the right. So 140. And it's that line. And this is minus 140. Yeah, and that's the top. I mean, the top line, the one that blocks from bottom, is at 40. The one that blocks from right is also at 40, and this is meant to be the top of it. Yeah, so they're drawn in a way that makes sense. Yeah. What doesn't make sense is the collision. Can we make the collision make sense though? Well, if we're looking at the top of the line, like if it's like this, we know this point, and we have some vector that we need to clip. So we know this point, which is the top. And we were looking at the x. We were looking at the x before, where it is on the x. Now we're looking at the y. flipped position is that. Yeah, that's fine. Column bound 1, column bound 2, so left, right, that makes sense. Left, right. Another thing actually is the row on the sprite what the collision is against. Okay, left, right is and bound 1, bound 2. Okay, so for the oh yeah, god damn it, this is not even what we want, right? We want to subtract. Okay, bound 1 is this, bound 2 is that, but if it's vertical, which we already kind of worked that out. Here. Until top bottom is horizontal, relative index is... Okay, so if it's not horizontal, then column bound 2 is that, and column bound 1 is that. So it's top minus, yeah. So it's like, yeah, okay. Okay, this is awful, but it is working, kind of. Awful collision, but functional. Hard to debug as well because I don't see on the sprite what I'm colliding against. It's one of the things I need to do later. Alright, what do we have here? I guess we have reading in the stages, which we're not even really doing anything with the stages. But that's one of the to-dos, is pull out collision information, right? So that's fine. Yeah, that's fine. Update, that's the collision stuff. That's that, alright. Start on collision. Oh boy. Alright, well, that's gonna be it for today. Thanks everyone.